Archimatix, tips for parametric models.
Parametric to static models. One of Archimatix's strengths is the ability to generate static geometry from parametric models. A parametric model makes use of relations within the Archimatix graph to dynamically build game objects according to its nodes and settings. These models can be preserved as static geometry either by stamping the mesh directly into the scene or by saving a Unity prefab to be instantiated later. Parametric models can be larger and more detailed than runtime models since they are not generated in real time. Archimatix can create secondary UV maps for light baking, and they are calculated into scene navigation. Static geometry can be exported from Unity as OBJ or FBX to be repainted, occlusion baked, and edited with external 3D tools. These tips will help a static workflow, but this advice will also help streamline runtime models.
Stamp versus prefab versus an Archimatix runtime prefab. Use the stamp button to leave static geometry directly in the Unity scene. Use the prefab button to save the static model as an independent prefab. To save a runtime prefab, drag the Archimatix model from the hierarchy to a folder in your project. This prefab requires that Archimatix is installed to use and edit.
Expose control parameters to access them in the inspector. Exposing any parameter means it will show up in a list in the inspector in the order it was exposed. Parameters in the inspector can be renamed with an alias, allowing you to create a control panel in the Archimatix component.
Look at the structure of an Archimatix model. A stamped model is the same structure as a runtime model. Notice how many child objects are created, and what kind of colliders each has. We need a happy medium between cobble game objects and single material geometry. If the model can fit within the camera view, it's probably better to combine meshes, but if a model is large enough that it can't all be seen at once, try organizing it into cobble parts.
The main material and the material nodes. On each Archimatix model is a main material on the component, which loads with the default purple grid. The entire model shares this main material, but each of the mesh construction nodes can launch its own material node. If the input of a material node is left blank, it will use the main material, and the UV can be scaled and offset, even rotated, locally on that node. If a new material is added to the input on the node, the main material is overwritten. This new material node can be distributed to other mesh nodes, but be careful, there seems to be a limit of 8 material connections. Archimatix will crash and you could lose any unsaved work. Hit Command-Z to undo as soon as you experience a problem with the graph.
Combine meshes with the same material. An Archimatix model can theoretically generate unlimited meshes, each with its own material, so don't think of a graph as one model. It is instead a game object with many individual child meshes. When you combine meshes, they become a single object in a hierarchy. It's also possible to create a convex mesh collider around the combined mesh that is more efficient than individual colliders, but also more accurate than a single box collider.
Do not combine meshes that use different materials. Archimatix might crash and you could lose any unsaved work. Hit Command-Z to undo as soon as you experience a problem with the graph.
If you want to use a texture atlas, create the atlas material first, and add it to the main material slot on the inspector. Use the individual material nodes to scale and reposition the atlas on each mesh.
The name of the node becomes the name of the game object in the hierarchy. Now that we've combined meshes with the same material, take a moment to rename the nodes with common sense labels. The translation and rotation of these nodes will be applied to the generated object. Avoid scaling your 3D nodes where possible, since scale settings will also end up on the game objects. Repeater, grouper, channeler, and instancer all apply their node transforms to their empty game objects. It's a good idea to clean up all the transforms on child nodes, to avoid unnecessary corrections on the parents.
The prefab instancer generates clones of the prefab. The prefab instancer populates the model with Unity prefabs, but as static models, they are no longer Unity instances. Since these items are clones, not references, you lose the prefab's ability to edit and update across the project. Consider using a proxy instead, and adding the prefabs and component scripts later, or dynamically at runtime. The proxies can be tagged to help them be identified by trigger colliders and scripts.
Grouper outputs size XYZ of its contents. There's a useful feature on the grouper node that shows the exact dimensions of the objects routed through it, size XYZ. The parameters are read-only, but it's helpful to know the dimensions of the model you are saving. With the grouper set at all zeros, in transform, scale, and rotation, the encapsulated model is ready to save as a Unity prefab, or to the Archimatix 3D library where it can be brought into other Archimatix graphs.
Duplicate and channeler. As parametric models become more sophisticated, they also become more complicated. It's not enough to just move a few parameters. Eventually, entire groups of nodes inside the graph will need to be swapped together. Use duplicate to create self-contained copies of mesh and groupers with duplicated 2D shapes feeding into them. The duplicated nodes can be edited to create modular variations. Each duplicate set can be fed into a channeler and selected with a drop-down list. Entire instruction chains can be forked through channelers to provide greater variation in the Archimatix model.